Welcome back. This is Miss Blanton's Algebra 1 homework review. It goes over section 6.4, page 93 in your workbook, number 1 through 4, 7, 9, 10, and 12 through 16. So stick around. Let's learn something. Number 2 has the same directions as number 1. Translate the verbal phrase into an inequality, then graph the inequality. So number 2 reads, all real numbers that are greater than 5 or less than or equal to -1. So we have two inequalities here that are connected by the word or. So when you read this sentence, you need to be able to recognize that you have two inequalities here connected by the word or. Yes, I just said that twice. So the first inequality, all real numbers that are. So x is going to represent all the real numbers. And we know that we have two inequalities, so we'll have one here and one here. What's the first one? All real numbers that are greater than 5. So we do the greater than sign, 5. Okay? Or less than or equal to, we know what that symbol looks like, -1. Okay, so we have the two inequalities. We have translated the verbal phrase into an inequality. Awesome. Now all we have left is to graph the inequality. So we have the number line. We know that we at least need to have -1 on here, and we need to have 5. Okay, so we have a point at -1, and we know to fill it in because it can be equal to. We also have a point at 5, and it's going to be open because it cannot be equal to. Okay, so we can graph whichever one we want first. They both have to be graphed, so we'll just decide whichever one we want. I'm going to do x is greater than 5. So x greater than 5. I like to plug in a test point because I need to know if I should bold the left side of 5 or the right side of 5. If I try the left side of 5, I'll pick 0. I'll do it here. Is 0 greater than 5? I've plugged in 0 for x. Is 0 greater than 5? No. So I do not bold this side. I bold this side. Okay, we've finished half of this graphing. The other inequality is x is less than or equal to -1. Plug in a test point. Is 1 less than or equal to -1? No. Is -2 less than or equal to -1? Yes, it is. And this is what an or compound inequality looks like. Because it can be this or that. X is greater than 5 is graphed here. X is less than or equal to -1 is graphed here. And that's how you solve number 3 also has the same directions as number 1 and number 2. Translate the verbal phrase, what we've been given, into an inequality, then graph the inequality. So first let's translate. All real numbers that are greater than or equal to -2.5 and less than 3.5. So we have a greater than or equal to, and we have a less than. Let's do the greater than or equal to first. So we have x and we have x. The first one, Greater than or equal to. Well, we know that greater than or equal to looks like this. Negative 2.5 it says. So that's what we write. And x must be less than 3.5. Less than 3.5. Okay? How else can this be written? Negative 2.5 is less than or equal to x. I rewrote this inequality with x on the right side so that we can combine it with this one. So negative 2.5 is less than or equal to x is the same thing as x is greater than or equal to negative 2.5. I flipped the side, so I flipped the sign. Okay? Now I'm going to combine this inequality with this one because now this x, I can just say, well, that same x must be less than 3.5. So you're going to see inequalities written like this that really can just be broken up to look like that. So we're going to be graphing these equivalent inequalities. I say equivalent because they mean the same thing. Okay, moving on. Let's get the graph. So we have negative 2.5 and we have 3.5. Remember, this is an and problem. So we're going to have some point, and they're going to overlap, right? And then that's where we're going to bold it in between. Let's try it out. We have negative 2.5. We'll do like negative 1, 0, 1, 2, 3, 3.5. Okay? So I've got my number line. I need a point at negative 2.5. I fill it in because x can be greater than or equal to, that's what tells us to fill it in, negative 2.5. Okay? Now I have 3.5. This one's going to be an open circle because there is no equal to with x less than 3.5. It's just less than. Okay? So what are all the x's, looking back at this half, what are all the x's that are greater than or equal to negative 2.5? That would be this side. Plug one in if you're unsure. Plug 0 in for x. Is negative 2.5 less than or equal to 0? It is. So we know that we can bold in that direction. 3.5. Plug in a number for x. I'll do 0 again. 0 in for x. Is 0 less than 3.5? Yes, it is. That tells us we can bold in this direction. Once again, if you would have tried a number on this side, if you would have plugged 4 in for x, is 4 less than 3.5? No, it is not. So we would not bold that side. So we know that we need to bold this way and from this point and this way from that point. So these are overlapping compound inequality. And that's how you solve number 3. 4 tells us to solve the inequality and then graph your solution. Okay? What's important when you see something like this with two inequality signs? You need to see this as its own side of the inequality. This is the inside of the inequality. And this is another side. Okay? This right here is one equality that I'm going to write here. Negative 3 is less than x plus 1. And then cover this inequality up. That's another inequality. So I'll write x plus 1 is less than or equal to 5. So if you cover this side, you see that one. If you cover this inequality with that side, you see the other. Okay? Alright, so now instead of this big complicated one, I just have one inequality here and one inequality here. However, these two inequalities have not been solved. They have not been solved because x is not by itself. There is a term with the x term, and that term on this one is a positive 1. So, if I want to remove the positive 1 here from this side, I would subtract 1. Subtract 1. What am I left with? Well, negative 3 minus 1 is minus 4. Negative 4. The sign will stay the same. X plus 1 minus 1 is just x. Okay, now we have solved this inequality for x. Let's do this one now. I see x plus 1 is less than or equal to 5. This x needs to be by itself, so I subtract 1 from both sides. So these 1's will cancel. So the 1's cancel, we're left with x. Bring down the sign. 5 minus 1 is 4. So we know that x must be greater than negative 4, and x must be less than or equal to positive 4. This is an AND problem, an AND compound inequality, meaning the graph of these two inequalities will overlap. I have an open point at negative 4, and I have a closed point at positive 4. Okay, all the points x that are greater than negative 4, they're going to be on this side. But I know that I also have to have points that are less than or equal to positive 4, so I stop shading at 4. This inequality goes off that way. X is less than or equal to 4 goes off that way. And this is where they overlap. This is how you solve number 4. You take the big inequality, you split it into two pieces. If you're struggling with that, cover one of the inequality signs. What do you have left? Negative 3 less than x plus 1. That's what we wrote here. Okay? Cover this inequality sign. X plus 1 is less than or equal to 5. That's what we wrote here. Okay? That's how you solve